Hello everyone, I'm Sanjul Madhurapiruna and I will be giving you an introduction into concurrency and modeling. What is concurrency? Concurrency implies that multiple computations are happening at the same time in a given system. Concurrency is a natural phenomenon where many things are happening simultaneously in the real world. A perfect example would be where there is a four-way intersection where cars are coming in from all four directions and they all want to cross the intersection at the same time. In this case, what would you think would happen without a traffic light system? There would be chaos, right? So when designing software for real-world systems, we must deal with this natural concurrency as well. It is especially important when there are interactions between concurrent activities. Why is concurrency important in computer science? The world is naturally concurrent, where essential computer systems like the internet, the operating systems like Windows, Linux, and Unix, all of them rely on concurrent activity. Concurrency allows for more efficient use of resources, it improves the speed of execution from true parallelism, and it also increases the reliability, that is, the fault tolerance. Concurrency is often the only way to solve problems which involve a temporal or non-deterministic or non-sequential aspect. Concurrent programming often results in superior program structure where code is written for the different tasks and a separate engine is allowed to take over to schedule those tasks. So, is concurrency difficult? Well, concurrency is very difficult because the advantages of using concurrency are almost always offset by having to deal with the dramatic increase in complexity of concurrent programs and systems. So some of the very major questions that have to be asked in order to determine how difficult concurrency is how do you get concurrent threads to synchronize when necessary so they don't make a mess of the shared resources? How do you avoid race conditions, deadlock, starvation? How do you ensure safety and liveness? Both two very important concepts in concurrency that will be explained later. And how do you recover if one of the nodes in a distributed system fails? Now we will move on to a case study where we will see how a bad understanding of concurrency actually led to human deaths. So, between June 1985 and January 1987, Therac-25, a radiation therapy machine, caused 6 known accidents with resultant deaths and serious injuries. It was found out that the errors in the concurrent program controlling the Therac-25 machine played an important role in all of those accidents. Interactions between the concurrent activities in the control program resulted in so much of erroneous control outputs that led to overdoses of X-rays. So this was also known as race conditions. So due to the sporadic nature of those errors, it caused significant delay in actually finding out the problem. Also, the mishap was mainly due to the designers of the Therac-25 system being unaware of the principles and best practices of concurrent programming. So in conclusion, why you must continue learning concurrency? A thorough understanding of the issues and problems that arise in a concurrent program, the principles and techniques of concurrent programming, and an appreciation of how it is practiced and applied in the real world collectively together is an essential knowledge base that every computer scientist and software engineer must grasp in order to gain the ability to design and build any complex computer system. So that's it for this video. We'll see you in the next one. Thank you.